So today topic is number theory. So 1, 2, 3, 4, so on are called natural numbers. Here I will take one equation, x minus 1 equals 0. You have to find out the solution for this one. So what do you get? X equals 1. So it has a solution in natural number. So because it is in positive integer, 1 is there. So it has solution in natural number. So I will take another one, x plus 1 equals 0. So what I get the solution here, x equals minus 1. But it has no solution in natural number. So they extended number system to integers. So here what I get, so on, minus 3, minus 2, minus 1, 0, 1, 2, 3, so on, are called integers. Here next I'll take another equation, 2x minus 1 equals 0. So x equals 1 by 2. Has no solution in integers. So they extended to rational numbers. Now I'll take another here equation, x square minus 2 equals 0. So x square is equal to 2. So x is equal to plus or minus root 2 again. So has no solution in rational number. So they extended to irrational number. So afterwards what is done, you get equation like x square plus 1 equals 0. So what you get, x is equal to plus or minus I. So has no solution because it has complex, so it has no solution. So in real numbers, so they extended number system to complex. So now here there are two binary operations. One is addition and another one is multiplication. So for addition they will use plus and for multiplication they will use dot. First one, closure property. closure property. For all a comma b belongs to z, that implies a plus b belongs to z and a dot b is belongs to z. Then this to satisfy, then closure under addition plus and multiplication and multiplication. Second, associative law. So here for all a comma b comma c belongs to integer z, that implies a plus b plus c equals a plus b plus c. So here for addition, this condition should be satisfied, and for multiplication, a dot into b dot c equals a dot b dot c. So if this condition is satisfied, then associative then associative under addition and multiplication. So next, identity law. For all a comma b belongs to z, there exists an element there exists an element 0 such that there exists an element 0 belongs to an integer such that a plus 0 equals 0 plus a. So we'll get a. So for all a is belongs to an integer, say. So here for multiplicative, so there exists an element 1 is belongs to z such that 1 into a equals a into 1 equals a. For all a is belongs to an integer z. Next here, inverse law. If a belongs to z, comma, there exists a unique integer minus a belongs to z such that a plus minus a equals or minus a plus a equals 0. Therefore minus a is additive inverse of a. Additive inverse of a. If a belongs to z, there exists a inverse 1 by a such that 1 by a equal into 1 by a into a equals 1. Therefore 1 by a is multiplicative inverse. fifth one here, commutative property. Commutative property. For all a comma b comma c, a comma b belongs to z, there exists a star b equals b star a. Next one, cancellation law. Cancellation law. So for all a comma b comma c belongs to z, then a plus b equals a plus c. So this implies b equals c for addition. This is for addition. Here for all a comma b comma c belongs to z, then a is not equal to 0. A is not equal to 0 and a into b equals a into c. That implies b equals c for multiplication. For multiplication. So last one here, distributive law. So if a comma b comma c belongs to z, then a dot b plus c equals a into a dot b plus b dot c. So here it implies a plus b into c equals a dot c plus b dot c. So this condition satisfied, then this is a distributive law. For all a comma b belongs to z, then a equals b or minus a equals minus b. So up to here it is basic. Now I will go for syllabus topic. Divisibility. Now here I take divisibility on the set of integer. So here let a and b be two integers and a non-zero if there exists an integer c such that b equals a into c, then we say a divides b, or a is divisor of b, or you can tell b is a multiple of a, or A is a factor of B. So remember these things. When A is a divisor of B, we write A divides B. So you have to remember this one. So it is in straight line. Now, or you can tell A divides B. Next, when A is not a divisor of B, we write here A does not divides B. So read as or write as A does not be divides. Sorry, A does not divides B. Here, example, first one here, 2 divides 8. So since here 8 equals, we have to divide with 2 here, 2 into 4. 2 4s are 8. So here 4 belongs to an integer, right? It belongs to an integer. So here why I taken 4 means here 2 is already here, 8 is also here. So only 4 is an integer. We have to write that one. So here minus 4 divides 16, since 16 equals minus 4. Here you have to divide with minus 4 only. So what you get? Minus 4 is 16, plus 16 you will get. So here it is minus 4, so you get. So here this one is new number you got. So new number is also what you get here, it is minus 4 only. So that's why minus 4 is belongs to an integer z. Now I'll go for theorem.